Hi there. We're going to take a look at the fundamental theorem of calculus, and this is just part one. So, more to come as we look at the fundamental theorem, but I'm primarily going to start with this approach, and that is to say that we know that the what we call the definite integral. So that's when we have bounds, we call them, that tells us where to start calculating the area and when to finish calculating the area. So if we have a definite integral and we have a derivative inside of it, we take the antiderivative. That would be the function whose derivative is this. And we then have to calculate that at the bounds. We take the upper bound, that's the one on the top, and we substitute in for x. And then we subtract and we substitute in the lower bound. And this is how we deal with what's called the antiderivative. Now we're going to look at a graph to kind of confirm what it is we found here, because we've been looking at finding those areas. Remember our Riemann sum work, okay? So we've got the function negative 2x plus 3. We want to calculate these definite integrals using the fundamental theorem, and then we want to also look at the area. So let's do the antiderivative first. So the antiderivative of negative 2x would be negative x squared. Think about if you took the derivative of negative x squared, you would get negative 2x plus 3x. And then I'm going to evaluate at my bounds. So my first bound, I'm going to put in the upper bound, I'm going to put in 1. I've got negative 1 squared. Notice how I wrote that. Plus 3 times 1. Then I've got minus, and I'm going to use a parentheses here. Then I've got negative 2 squared plus 3 times negative 2. Be real careful with all the negatives. Okay, so 1 squared is 1, put a negative on it, plus 3, minus negative 2 squared would give you 4, but you put a negative on it, makes it negative 4, plus negative 6. Okay, negative 1 plus 3 gives me 2, minus, looks like negative 10 there, looks like I'm getting 12. Okay, now realize what that area is. It's from negative 2 to 1, negative 2 to 1, and it's from the x-axis. Let me do that in pink so I think you'll be able to see it a little bit better. Negative 2 to 1 from the x-axis to the curve. Now this shape should look familiar to you. That is a trapezoid. Or maybe you see a rectangle and a triangle. Either one works for me. But let's check out that trapezoid. We do it as 1/2 times the height. That is 1, 2, 3. And we add the bases. That is 1 plus 7. So I've got 1.5 times 8, which is 12. And friends, that's what we got when we did the antiderivative. We did the fundamental theorem. They should come out to be the same. Okay. All right. Now let's do the second one here. Same function. So good thing we've already found the antiderivative. Negative x squared plus 3x. And this time we're going from 2 to 5. I'm going to plug in the upper bound first. Then minus, and I'm going to plug in the lower bound. Okay, so 5 squared is 25, it gives me negative 25, plus 15, minus 2 squared is 4, put the negative on it, 3 times 2 is 6. Negative 25 plus 15 is negative 10, minus 2, and that gives me negative 12. Okay, now look at the area. Why is this area negative and why are we okay with it? Let's take a look. This time we're going from 2 to 5, and it's between the x-axis and the curve. Notice this area is located below the x-axis. So the negative here is not telling us that the area is negative, it's telling us the location of the area. And that is the only reason why we're okay with the area being negative in this case. Okay. You feeling okay about that? Because we're going to keep locating different areas, all right? Same curve. Good thing we've already got the antiderivative down. We've just got different bounds this time. Okay? So let's plug them in, plug in our bounds. Let's see what we get. So 4 squared is 16, put a negative on it. 3 times 4 is 12. Negative 1 squared is 1, put a negative on it. Okay, so I've got negative 4 here minus negative 4. That gives me 0. So how can area be 0? Let's take a look. Let's shade what we are trying to find here. We're going from negative 1 to 4. So this area up here is above the x-axis. And this area down here is below the axis. So remember, and when the area is below the x-axis, it's negative. So why would this area tell me it's 0? Because from negative 1 to 4, the area above the x-axis is equal to the area below the x-axis, giving you a net area of 0. That's why the antiderivative work, the fundamental theorem, is showing us 0 as the answer, because this area up here is equal to this area down here, giving us a net area of 0. Okay, so let's keep going. I've still got same antiderivative from negative 1 to 3. So let's put in those bounds. So 3 squared is 9, put a negative on it. 9 minus, now I've got negative 1 squared is 1, put a negative on it. So I've got 0 minus negative 4. So I've got 4. Okay, let's see why this one came out to be positive 4. So I'm going from negative 1 to 3. So I've got negative 1 here. And I've got from there to 3 here. So notice we did have some negative area, okay? But the positive area, when you add the positive with the negative area, you get a net of 4. And that's because there's more positive area than there is negative area. Okay, now we're going to do the last one here. But for this one, I want to shade it first. I want you to kind of think about, is it going to be a positive or negative answer? We're going from 0 to 5. So 0 to there would give me positive area. And then from here to 5 would give me negative area. Okay, so what do you think? Is it going to be a positive area or a negative net area? You're right. It's a negative net area because that negative area is a lot bigger than that positive area. So let's confirm it with the fundamental theorem. Love when the bounds come out to have the 0 as a bound because it makes it a little easier. So I get negative 25 plus 15 minus 0. So I get a net area of negative 10. And again, we already knew that ahead of time because we could see the negative area was going to be bigger. So I hope this helps with the fundamental theorem. We'll keep practicing with this, with the bounds and the antiderivative and such. But don't forget to leave me a comment below if you have questions or you want me to do a video over some certain type. I'd be happy to do that. And don't forget to hit like and share so that, sorry, like and subscribe because you get a notification every time a new video is posted. Bye for now.